Hi, my name is Kyle Green, and my project is the Epoch FPGA phone. The goal of this project was to develop a smartphone-like device from the ground up. So we started with designing our own processor, which is a 32-bit MIPS-based processor. And we designed our own peripherals to attach to that, such as an SD card, serial port, touchscreen, other debug devices, and went all the way up to the software side, such as assemblers, our own custom compiler, and operating system developed for this system. This is a setup of our project. As you can see, we have an SD card reader here. On our SD card we have the operating system and program stored to be loaded by the processor. When the processor goes into a reset, firmware within the processor loads the operating system out of the SD card and places it into RAM to be executed. We also have, as with all modern smartphones, a touchscreen. This touchscreen is a resistive screen off of a Nintendo DS. We have a serial port here for console input and output, and we also have a VGA display, which is not connected currently due to not having a monitor to connect to. However, it still exists. We also have a 7-segment display and switches here for debugging. As you can see now, there is a program running, outputting values. These values are the values that are being read off of the touch screen. So, if I move this here, you can see when I touch it, currently it is displaying the Y values, and if I press this button here, it will display the X values. A very simple program, but it displays the capabilities of the touchscreen. The main goal of this project was not just to make a smartphone, but to make a smartphone that was easy to use, easy to develop for, easy to modify. We'd like to be able to give these to students. Smartphones are one of the main hot things these days, so if a student can have a smartphone and mess with it, add his own peripherals, modify the operating system, this would be an excellent way to get students interested into computer science and computer engineering, digital design. Here's a very simple program that can be run on the processor. It just counts up and constantly outputs the value onto the 7-segment display. As you can see, it's very standard C. It uses a special function pok, which outputs to the 7-segment display. However, other standard functions, such as functions in standard.io, string.h, and other limit.h, a few other header files are available. The processor also allows for interrupts, so I have an interrupt handler here that just outputs the value, the address of the interrupt onto the serial port, so it will be displayed in the console. And now the program that we just looked at has been compiled and is running on the processor. We can see that it is counting too fast to be displayed for the lower 16 bits, but the upper 16 bits you can see counting up. You can also see the bootloader has outputted the program name into the console, and when I send an interrupt by, for example, typing a letter, the value 6, which is the port number for the input serial line, is displayed. If I hit a button which is corresponding to the second port, 2 is displayed. And that is my project. Thank you for watching.